Good morning friends. I hope you are following the thermodynamic video lectures. Now we are in the thermodynamic classes in that adiabatic process. The last class what we discussed means what is the essential conditions for the adiabatic process. If you not followed the last video, please go through the last video. Now today our goal is to derive the PV relation in adiabatic process, or they may ask the question like this: proof for the PV power gamma is equal to constant. As we know, in adiabatic process the essential conditions are the walls must be completely insulating walls, and also the process must be done in a short period of, that is a rapid time interval. It is very fast the process must be done. Now let me come to our situation. We are a ideal gas in a system, in a cylinder. So let's assume the number of moles of the ideal gas. Let's assume the initial condition of the piston is here. So the number of moles of the ideal gas is equal to n. N is equal to number of moles of the ideal gas. Now here is the ideal gas is there, up to here is the ideal gas is there. The initial state of the system is equal to, the pressure of the initial state of the system is equal to P1. The pressure of the initial state of volume of the initial state of the system is equal to V1, because of here we are having. Now we are allowed to expand the gas. Then the gas is expand suddenly, the piston is move upward direction, then gas is enclosed, the gas is expand up to the second state of the system, then the gas is also expanded up to here, the gas is expanded. Then the second state of the system is represented with help of the another values of pressure P2 and volume is equal to V2. As we know, this process is an adiabatic process. There is no any exchange of heat into the system from system to surrounding. Then Q is equal to constant in the system. Then what will happen if the Q is equal to constant? Then dQ is equal to 0. Because of Q is equal to constant, the change in heat energy of the system is equal to change of energy, heat energy of the system is equal to 0. Then we are taking the first law of thermodynamics. We are examining the first law of thermodynamics. We are recalling from first law of thermodynamics. What is the first law of thermodynamics is telling? The first law of thermodynamics telling that the amount of heat energy supplied to the system is equal to change in internal energy of the system and external work done. This is the formula. As we are in the adiabatic process, say we are in the adiabatic process. So in the adiabatic process, dQ value is equal to 0. Then the first law of thermodynamics is converted as 0 is equal to du plus dw. Then we can write this equation as, from this equation we can simply say that what is the value of du, and we already known that one. What is the fundamental formula for the du? Du is known that NCV into delta T, that is the dt. And also dw also we know this one. We are having the formula for the P into dV. These are the formulas are there for du and NCV, du and dw. Then first law of thermodynamics I am writing once again here, du plus dw is equal to 0 in adiabatic process. I am substituting the du value, number of moles into specific heat capacity at constant volume dt, and P into dV is equal to 0. Now first of all we are concentrating on n to eliminate of this n into dt. We are going to eliminate this n into dt term. For this one what we are doing means we are taking the ideal gas equation, because of what we are taking the system is an ideal gas. So from ideal gas equation, so the ideal gas equation is telling that PV is equal to nRT. Now in our process the pressure and volume both are variables. That's why we are partially differentiating this equation with respect to pressure, volume and temperature. In our process, these values are not constant because of all are variable parameters, but only number of moles is constant and only the ideal gas constant is a constant. Remaining all terms are the variables in our adiabatic process. That's why we are partially differentiating this one. First of all, I am keeping the pressure is a constant. I am differentiating V that equal dV. Second, I am keeping the volume is the constant. I am differentiating the first term that is equal to dP. Then here I am taking differentiating this one, n is the constant taking out, r is the constant taken out. So the remaining term t is the differentiating that is equal to dt. Now here we are getting this n dt term is there. Now I am sending r to other side, then n dt is equal to 1 by n into where it is sending to other side already this is the r is in the multiplication. If we send the other side, it will come to the division. So P into dV plus V into dP. This is the formula we are getting. Now let's go the what is the formula we are having in this one. Let's assume this is the equation. Now I am writing one more time the first equation. The first equation implies that NCV dt plus PdV is equal to 0. Now I am substituting here n dt term in this equation. Just now we are getting, let's assume this is the equation number 2. Then 1 implies with help of the second equation by substituting the second equation value. Then what is the value we are getting? CV term is already there 1 by r into CV term already is there 1 by r into. So remaining term I am taking. So P into dV plus V into dP plus PdV term is there, that is equal to 0. Now I am taking the LC here. So sending to R this side and also sending to R the other side. Then what we will get? CV P into dV plus CV into V into dP plus R into P into dV is equal to 0. This is the formula we are getting. Now will you please look on this one. Here the CV VdP is there and PdV is there. Here also PdV is there. Here CV is there. Here R is there. Now I am taking the common term of PdV. So the remaining terms are the CV plus R is there. Now that is equal to PdV plus CV VdP. We are getting that is equal to 0. We already known the Mayer's relation. What is the Mayer's relation? Mayer's relation. Mayer's relation, what is the formula it is telling? That is equal to Cp minus Cv is equal to R formula is there. Then Cp is equal to Cv plus R we are getting. Then this value I am going to substitute in the above equation, that is equal to Cp into Pdv, Cv into Vdp we are getting. That's why I am writing here. Now once again I am writing here. So let me recall this one. Cp into Pdv, Cp into Pdv plus Cv into Vdp we are getting. Once again I am recalling. So Cp, this value is the Cp into Pdv plus Cv into Vdp, that is equal to 0. Now I am sending to other side this one, that is equal to Cp into Pdv is equal to Cv minus Cv into Vdp. So we already known that Cp by Cv is equal to constant, that is equal to adiabatic constant, we will denote it with gamma. Now I am sending Cv this side, I am sending P this side, I am sending V this side. What will happen? Then Cp by Cv into dV by V, that is equal to negative term of dP by P. This is the value we are getting. Then what we will get? This value is equal to gamma into dV by V is equal to minus dP by P. Now we are integrating this above equation with the perfect limits. Now I am taking one more time that equation. Gamma into dP by P is equal to, gamma is once again recalling, gamma into dV by V we are having. So gamma into dV by V is equal to negative term of dP by P. Now integrating this equation, integrating above equation with limits. That means we are starting with the initial state of volume is equal to Vi. We are taking initial volume is equal to V1, the final volume is equal to V2. In the similar manner, initial pressure is equal to P1, the final pressure is equal to P2. Like this we are moving. So the gamma into integral of 1 by V into dV, the limits are V1 to V2, that is equal to negative term of gamma into negative term integral of P into dP. The initial pressure is equal to P1, final pressure is equal to P2. Now you already well familiar with the formula of integral of 1 by x into dx is equal to log x base E, and specify we need not to specify the base E format. It is the, if we are not writing that function, the base is must be E. Then gamma into log of V, in this term I am taking, the limits must be applied, that is equal to V1 to V2, that is equal to negative term of log of P from limits are P1 to P2. As it is a perfect integration, they need not to write the constant of in this integration. So now I am going to apply the limits, upper limit and lower limit. Then gamma flower bracket open log of V2 minus log of V1, just I applied the limits, minus log of upper limit of V2, upper limit P2 minus lower limit P1. So you are very familiar with, in the mathematical function, log of A minus log of B is equal to log of A by B. This is the small formula. So with the help of this one, here is the log V2 minus log V1 is there, here log P2 minus log P1 is there, that is equal to gamma into log of V2 divided by V1. Now one more condition, so log of V2 by V1, that is equal to negative term of log of P2 by P1. So you have one more condition, log of A by B is equal to, can be written as the log of B by A. Now we are using the reverse condition, minus log of B by A is equal to log of A by B. Here we can interchange the denominator as the numerator, numerator as the denominator, that is equal to gamma of log of V2 by V1 is equal to log of P1 by P2. You already well familiar one more formula, logarithmic, log of n into x is equal to log of x power n. This formula is there. Here gamma is there, then we can send to this side, so that is equal to log of V2 by V1 whole to the power of gamma, that is equal to log of P1 by P2. So you have one more formula, log of A base E is equal to log of B base E is equal to A must be equal to B. This is the formula we are having. That means here base E is there, here base E is there, these two functions are equal, then this function must be equal to the another function, right side function. Then what we can write, so that is equal to V2 by V1 whole to the power of gamma is equal to P1 by P2. P1 by P2. Then that is nothing but V2 power gamma divided by V1 power gamma is equal to P1 divided by P2. Then I am sending P1 terms one side and P2 terms other side, that is equal to, so P2 V2 power gamma is equal to P1 V1 power gamma I am taking. So I am writing in order, that is equal to P1 V1 power gamma is equal to P2 V2 power gamma. So that we are generalizing this equation, that is equal to the P1 V1 power gamma is equal to P2 power V2 gamma is equal to constant. Then generalizing the equation, PV power gamma is equal to constant. So this is the relation in between the P and V in an adiabatic process, where the P and V, the relation is equal to PV power gamma is equal to constant. That is the value in the relation in the adiabatic process. Thank you.